We got these three routers. I'm going to put them all in same area. First thing, as I said, we are going to do authentication. There's something special in OSPF authentication. What is that? OSPF has got three type of authentication. First type is the default, which is called null authentication, which means there is no authentication, but that is also considered as type, and the type is identified with the number 0, type 0 authentication. Secondly, we have type 1 authentication, which is plain text or clear text. What does that mean? When a hello packet goes, or any OSPF packet goes, it may be an update packet or whatever, the passwords will be sent along with the updates or hello packet in a clear text. This is what type 1 authentication, clear text authentication. It is good to have authentication because we do not want to learn routes from an intruder. See, routing table is the path determining device. Router is the path determining device. To a destination, if the path is via attacker's network, then problem. So what will happen is sometime the attackers will try to provide routes to reach yahoo.com to your network. So for you, your gateway will be the attacker's network. You will not be able to identify that we are under attack, because when you try to surf yahoo.com, it works very fine. Yahoo is opening for you, so you did not get any doubt. Traffic is going successfully, but it is going via attacker's network, because the route in the routing table shows attacker's network as the next hop to reach Yahoo. It is because the attacker has formed OSPF adjacency with your router. After forming OSPF adjacency, he has given routes with better metric, so that your router will choose the attacker's path instead of going via original genuine ISP. Attacker is providing route same like what ISP is providing, but the difference is ISP's metric is bigger than attackers, which means ISP's path will not be preferred because the metric is high. Lower the metric, better is the route. Attacker is giving low cost path, so automatically router will go via attacker's router network. How do you prevent this? Authentication. Before forming neighbor, we want to authenticate. We would like to authenticate and then form neighbor. So you will be forming neighbor only with genuine OSPF neighbors, not with rogue OSPF, not with attackers OSPF. So authentication is good in any routing protocol. Authentication should be enabled. Every routing protocol supports authentication, and it is good to enable authentication. So today we are focusing on OSPF authentication. As I said earlier, OSPF has got three types of authentication. Number one, null authentication, which is type 0 authentication. Secondly, we have clear text. Clear text authentication, which is type 1. Thirdly, we have MD5 authentication, type 2 authentication. Clear text is something better than nothing. Clear text is like something better than nothing. No authentication is dangerous. At least you have some authentication. MD5 is the best. Why? Clear text will advertise in all the hello packets, in all the update packets. Clear text authentication will carry the password in a clear text manner. So if someone is a small techie guy can sniff packet and see the password. But when you enable MD5 authentication, password is not sent. Hash value is sent. No one can decrypt that hash value other than genuine Ospf routers. So only when two routers have same password, let's say Cisco 123. If both have got same password, and if both are in same time zone, only they can decrypt this, others cannot. If an attacker here tries to decrypt this MD5 hash, he cannot because he don't know the key to open the hash.
So what is the meaning of same time zone? So
Means when a hash is created, the time in the device is copied in the hash. The time of the router. The router is having clock, right?
yeah.
The time of the router is copied and hashed. Why, you know? Because you may be changing the password after 5 minutes. Now, if someone uses the old password, he will not be able to successfully get authenticated. So along with the string, means when I say string, it means password, and then the key number, we'll be configuring key 1, key 2, the key ID. Even the time matters. If the time is not in sync between the routers, the authentication will fail. If one is in Philippine time, another one is in India time, you need to follow UTC time in both, universal time clock. Otherwise, problem. Right? So, authentication includes time also. So, when you enable authentication, if you see authentication is not working, then there may be mismatch in time. That's how we troubleshoot. Check the timer. Okay, now let's not get into those areas. Let us now go and see how to configure this. Type 1 authentication can be or may be vulnerable. Someone can use some Wireshark or something to sniff packet and see the password. But MD5 authentication, even if you sniff, you will see only the hash value, which cannot be reversed by someone. It can be reversed only by genuine neighbor. Right now, first of all, let us configure IP addresses of these routers. I would like to use Notepad. These many loopbacks I'm creating for learning route filtering in OSPF. It's actually 24, not 14. Now what I want to do is I want to enable OSPF also now router OSPF 1. See, I'm going to give a router ID. I'm going to give a router ID. That router ID that I gave doesn't not necessary to be an IP address on an interface that we know already. So what does this mean? This means that the first 2 octet is 192.168. If the first 2 octet is 192.168, it should be part of OSPF area 0. So on loopback 0 and loopback 1, if you notice, we have 192.168 in the first 2 octet. So those two interfaces are going to be part of area 0 now. Next. Now because of this command, loopback 2 and loopback 3 is going to be part of area 0. One more network I need to advertise. which is we can also do like this. I'm masking it completely, all 4 octets. So now only G00 will be running OSPF. This I'm going to paste it on router 1. Okay, host name. Let's also give host name in the notepad. All right, next is let's do router 2 configuration. In router 2, I don't have much loopbacks, so I delete all this. Router 2 is the host name. G00 is going to have 2 here. So G0/1 will have 10.23.2. The router ID I want to give manually to the 2. This I don't want. Now I'm going to run OSPF on both the interface using just one command, for which I need to do this alteration to this. Or does this mean if first octet is 10, all interface that has got first octet 10 should be part of alias 0, which means both the physical interface G00 and G01 of R2 will be running OSPF. Second, the third router. The third router has got only one interface. And this will be 3 here. Right. I also want to add a loopback interface in R3. And then this is on router 3. Now what I'm expecting is reachability between R3's loopback and R1's loopback. Let's ping and see. Ping 192.168.1.1 with the source 33, 33, 33, 33. See, the ping happens. Actually, this is 1.1 and 2.2. So if I'll ping to the 2 also, it should ping. Likewise, 172.16. 1.1 also it will ping. All right, this is before authentication. Let's enable authentication. Between R1 and R2, I'm going to enable plain text authentication. Between R2 and R3, I'm going to enable MD5 authentication. Before that, I want to show you how the OSPF packet looks in the debug. Debug IP OSPF packet. If you notice, wonderful. This is what I want. I'll stop this. If you notice here, the date, time, month, and it's type 1 hello packet sent by router 2 to this multicast address. Version 2 means IP version 4 version of OSPF. Type 1 means hello packets. The length of the packet is 48. The router ID which is sending me this is 2.2.2.2, and this packet belongs to area 0. For area there is 32-bit reservation. That is why it shows like that. Even though I just put area 0, it shows area 0.0.0.0. Check some value. See, the authentication is null authentication. Type 0 authentication. When I go here now and interface G0/0, this is how we enable authentication. IP OSPF authentication key chain. Sorry, no key chain is needed for this. IP OSPF authentication key. Cisco 123. IP OSPF authentication simply means plain text. All right. We are using type 1 authentication, plain text. Now you will lose the neighbor very shortly. The neighbor will go down. You see, show IP OSPF neighbor. The timer is now going down. When it hits 0, what will happen? The neighbor will vanish. Debug IP OSPF packets now. I want to show you that it will start telling that we are using type 1. You see, we are using type 1. Who? Router 1 is sending out type 1 authentication. Whereas what is coming in from router 2 is type 0 authentication. So because of that reason, the neighbor is gone. Full to down. The neighbor is gone down. See, it is very clearly saying that we are using type 1, but the incoming is type 0. You can also type another command to know this better. Debug IP OSPF adjacency. This will show you more clearly why the adjacency is not forming. You see? Mismatch in authentication type. It is not saying password is mismatching. Type is mismatching as of now. First the type should match. Then only it will check the password. It is saying we are using type 1, but what is coming as an input is type 0. What is coming as an input is type 0. We are using type 1. All right. So now what is next? We have to enable authentication on router 2. Router OS. No. I'll go under the interface. Now before that, let's try pinging from router 3. Earlier this ping was happening, but now the ping won't happen. Because we lost the neighbor between R1 and R2, there is no chance of router 3 knowing about this network. You see, show IP route OSPF, there is no route from router 1. There is no route from router 1. What is next? IP OSPF authentication. IP OSPF authentication key. What key we gave there? Does anyone remember? What is the password that I gave here? Cisco 123. You should use the same password. Now you will see neighbor coming up. The neighbor will come up. Because both the side, see, neighbor has come up. Now if I go back to router 3 and check the routing table, I'll see the routes shortly. It will come. See, it has come. See, there is no need for you to enable same authentication between router 2 and 3. It is per interface. It's not necessary for you to enable authentication between router 2 and 3. Only if it is necessary you do. Because we enabled authentication between 1 and 2, to learn the routes of 1 on router 3, there is no need for you to enable authentication between 2 and 3. There is no logic, there is no connection. It is per interface. So now the ping should happen. Right. Now next is between router 2 and 3, I'm going to enable MD5 authentication. MD5. If you now go to router 1 and try pinging 33, 33, 33, 33 with a source of 192.168.1.1, you are able to ping. Which means the loopback of R1 reaches loopback of R3. Let us go and enable authentication between router 2 and 3. I'm on router 3. Under the interface, IP OSPF authentication. You see, key I'm going to give different key this time. This time I'm going to give B, E, A. Something like that, just like that. This is the password. And IP OSPF authentication message digest. So even now you will see the neighbor will go down. Debug IP OSPF. See, not a valid key, send the keys available. Let's debug first. OSPF adjacency. Also, I would like to enable debug IP OSPF packets. Okay, the adjacency says that what is received from router 2 is 0. But what we have is type 2, not type 1, type 2. So mismatch in authentication type again. See, the neighbor has gone down. Because of that, neighbor is dead. The neighbor has gone down. The reason is the authentication type is mismatching. Now, let's go and enable on R2 authentication. On R2, interface G0/1. You remember on G00 of R2, I have enabled clear text authentication. On G01, I'm going to enable MD5. As I said, it is per interface. IP OSPF authentication, message digest, IP OSPF authentication, And the key that I gave is something I gave. B. Now you will see neighbor coming back. So in R1, if you ping now, the ping won't happen. Okay, its neighbor has come so soon. The neighbor has already come. All right, because the authentication match, the neighbor has come. You're able to ping. Show IP OSP of neighbor. The neighbor is up to the date. See, 36 timer, 33, 32, 31, again 39, which means every 10 seconds the hello packets are coming. After 31, it just gone to 39. Now what we are going to do is, what is this error? No valid authentication. Send key is available on interface key 00.
So I think IPOSP message digest, that is not given.
No, it is given. This is not a relevant message. See, sure run. If it is not given, it won't form neighbor and there won't be reachability.
Oh, okay.
It is given, I am very sure. See, it's given here. Also,
In the route.
show run interface G0/1. In this version, they have something additional check. It is matching on either side, there is no issue.
Okay.
Fine. What is next we are going to do is, we will change the password. Here I am going to change the password and let's see the debug how it looks. On R3, debug IP OSPF adjacency. Earlier, when the type was mismatching, it very clearly said authentication type is matched. We are using type 3, the other guy is using type 0. But now, let us see what happens if I change the password. I go into the interface and then I'll put the password as BEEE. I removed that A, I replaced with E. So if you now go, wait and see in R3, it will start. It should start reporting debug IP OSPF. This is something kind of a key ID. You can also give optional key ID. In this particular version, it is asking for key ID. That's not a serious issue now to talk. We'll check that one later. I'm looking for, I want it to say that authentication key mismatch. That is what I'm expecting. The neighbor is, oh look at, no. Why the neighbor has not gone down? Debug IPOSPF packet. Both sides we have type 2 authentication. That is not a problem. But the authentication key is not correct on either side. Debug IPOSPF. There is another command called events. Oh, I think I already got it. Look at this. The key ID is the problem. No. Still, I'm not seeing what I want to say. Debug IP OSPF events. Sequence number is same. Key ID is 0 both side. Correct. I think once authenticated, it won't check the key. The EAGRP will clearly check. Process. I'm restarting OSPF process so that it will check the key. Okay. Now I'm expecting the complaint. It should tell authentication mismatch. Oh my god, but there is a TRB direction. What happened? Show IP OSPF neighbor. Oh, there is a neighbor. How come? Show IP OSPF interface G0. Show run interface G0/1. I have different password. Interface G0/1. I'll just shut down. I don't have another option to fix this. Okay, there is no neighbor. I'm going to bring it up now. You will see that complaint which I'm trying to show you. The authentication type is 2 on both sides. That looks okay. Two-way communication, what? This is not fair. Preparing database exchange. Retransmitting DBD. How come? How is this neighbor found? The neighbor is already found and the key is not matching. Very dangerous. Let me try changing complicated password. But again it is found neighbor. I think I need to restart the router only, then I can show you a clear picture. I think the old buffer, the MD5 hash is in the buffer. That's why this is keep on showing neighbor for me. Neighbor, I still see neighbor with R3 even after changing password. So when you do, you just restart the device and see that neighbor should go down. Anyway, let's go to the next topic. Due to the time, limited time, I would like to go to the next topic. Being now 192.168. Okay, we got reachability. Now what I'm going to do next is the route filtering using prefix list. We can filter routes. See, right now I'm able to ping from router 3 to router 192.168. Assume I do not want to ping. Please pay attention. I do not want R3 to ping this first one, 192.168.11. All the rest it can ping. You understand? I do not want only the first one. I don't want router 3 to know about this network. How can you do this? You can do in any router. You can even do it on router 3. You can also do it on router 2. But if you do it on router 1, it won't even go to router 2. You don't have any problem with router 2. Router 2 can ping. You don't want router 3 to ping. So you can put a filter here and saying, when you send the update, don't send this one. When you send the update out. The other way is you can write the same filter here and say, when you receive the update in, don't accept this update. Filter this. You understand? So we're going to see how to do this. And I'm going to use prefix list. You can also use access list for this. Anyone has got any question? Did you understand the scenario? Please talk. Did you understand the scenario?
Yes, sir. Yes, sir.
All right. So right now, if you go to router 3 and check the routing table, show IP route OSPF. I'm learning 192.168. I don't want to learn this. The rest all I'm okay. I'm okay with the other. But this one particular subnets, I do not want this to come in here. So I want to do it on router 2. First, we have to write a prefix list. IP prefix list. Give any name. I'm going to say OSPF our route filtering policy. Optionally, you can give sequence number. If you don't give also, it will give automatically like 5, 10, 15. I'm going to say sequence number. It's okay to give 1. And here I'm going to say deny 192.168.1.1 deny /32. I'm saying deny this particular one. Just use the up arrow and change this to sequence number 2. And here I'm going to say permit. What does it mean, permit? All. 0000 means what? All. Permit all subnets which are less than or equal to 32. Means even if it is /16 subnet, advertise. Even if it is /8, you can permit. If it is 24, also permit. Less than or equal to. Bam. Sorry. Okay, I need to say any subnet mask, any mask. Okay, any network, any subnet mask. The mask also can be anything. From 0, I need to say from. This is from 0. This is from 0, lesser than or equal to 32 prefix length. Any subnet mask, any network, any subnet mask. That's the meaning. Yep. And then I have to apply this under OSPF. So this is the prefix list name that you need to copy. I'm going under router OSPF 1. Area 0. Filter list. Use the prefix list. The prefix list name is this one. You see, in or out. Should I put in or out? Out. When you send the update out to R3. Because 192 is in the left. You're giving to router 3 which is in the right. So we have to say what? Out. Bum. Now if you go to router 3 and check. Show IP OSPF database. show IP route OSPF. Yeah. Sorry, I'm still having this. Let's clear IP. Let me check once what I configured in the prefix list. Show IP prefix list. Oh, it is correct. 192.168.1.1. Okay, you know, this is very big mistake I have done. We need to do this on the ABR, but unfortunately here all the routers are in area 0. So quickly what I'll do is I'll go under G0/1. No, I'll remove that first. Router OSPF1 do show run section router. You remember we do summarization, all those things in the border. Prefix list also should be done in the border. Here what I'm going to do is I'm going to remove this. And now I'm going to say network 10.12.0.0 is in area 0. Whereas network 10.23 is in area 1. I'm making router 1 and 2 to be in area 1. Let me also do the same correction on router 3. Router OSPF1 do show run section router OSPF. I'm going to remove this and also this. I'm going to put them in area 1. Okay. Well, now it will work. Now this will work very clearly. If you check the routing table now, from area 0, when the update is coming and when it is about to go to area 1, it will filter 192.168.1.1. Show IP OSPF neighbor. You see you have neighbor. Show IP OSPF, show IP OSPF interface brief. This is in area 1. Show IP route OSPF. Look at this, 192.168.1 is missing. So remember, in OSPF, everything is only on the border, whether you are doing stub or summarization or distribution list, everything should be done on the border. So if you try pinging now, the ping won't happen. 192.168.1.1 on ping because the route is not coming. It's suppressed. It's suppressed. All right. So you can do some examples like this.